and welcome to another screencast where this time we'll be discussing bone formation and also bone growth and remodeling here. So by the end of this, hopefully you should be able to describe and explain here how bone forms, that is in a fetus. This is before we are born, and then also describing the events of bone remodeling, right, as well as bone growth here, so how our bones get larger. So these images here show fetuses, and the reddish-orange area here, all these orangey area here, as well as in this chicken, another vertebrate here, just to show you here the red and the blue. This is all cartilage, right? And it's primarily hyaline cartilage. And that hyaline cartilage is a model for bone growth, right? And at one point in our development, all of our bones were made of this hyaline cartilage, and from there, then that hyaline cartilage becomes bone in a process called ossification. Ossification. Right? So the bones become ossified, or they turn into bone. Or sorry, the cartilage models turn into bone. So some cells that are involved with this are, of course, hyaline cartilage cells. So some things that we're going to be seeing here a lot is this prefix here, chondra, which means cartilage, right? And then osteo, which you know from other screencasts means bone. Right? And so we're going to have chondroblast cells, which are going to be cells that are forming cartilage. And then we are going to have chondrocytes, which are cells that are maintaining the cartilage. And of course, from other screencasts, we know that we have osteoblasts, we have osteocytes, and we have osteoclasts. Right? So we're going to be seeing these cells here. I do want to just remind us here of what hyaline cartilage looks like here. So this is a chondrocyte in a lacuna, and that chondrocyte is, of course, secreting out this extracellular matrix, which is highly water, and it's mostly water, and it's very little fibers here, right? And that is collagen fibers. Just a little bit of collagen fibers in there, right? But it is mostly this watery watery-based extracellular matrix that has been secreted by these chondrocytes. So that is how all of our bones start out. And then there's this process of ossification here. So most bones form using hyaline cartilage here as a model or a scaffolding on which to build the bone. So what we see here is a light micrograph of what's happening here in the cartilage, right? And then the ossification of the bone down here. So this up here, this zone of resting cartilage, this is number 1. This zone of proliferation is number 2. Number 3 is this hypertrophy area. Number 4 is the calcification area, and number 5 is the ossified bone. So basically what's happening here in the cartoon is that we have chondrocytes. Here is a chondrocyte in a lacuna, here's a chondrocyte in the lacuna, and basically what's happening is that these chondrocytes are reproducing rapidly, right, in early bone here, and they're then of course producing this hyaline cartilage. And so as they reproduce themselves, they sort of pile up going in this direction, and as they do that, they then increasingly secrete their extracellular matrix, their ground substance here, and so you see that they become farther apart, so the gap between them becomes farther apart. So these are younger sites here. So what happens is, as these cells mature, they begin to then also expand, right? And as they expand, that is known as hypertrophy. So the cells actually get a lot larger, right? And they become mature. Right? After they mature, they actually begin to die, and the matrix becomes calcified. So as the chondrocytes die, the matrix becomes calcified, and then from that you have ossification taking place. The calcified cartilage so on this diaphyseal side of the plate is replaced by bone. So what we see happening here is that you have osteoblasts that are sort of invading this area that is vacated by a dead chondrocyte cell, and as those osteoblasts will inhabit this area, and you see that here, they're just going to continue moving up into this area here, and as they do so, they begin to secrete even more calcified matrix, and this is how, of course, we're getting trabeculae formed. So this, you can see right here, this pinkish would be a trabeculum, right, of spongy or cancellous bone. So this is all cancellous bone down here, right? So maybe want to pause and take a look at that again before we move on. So that basic pattern there is we're going to see that happen here in bone formation. So several steps here, 7 steps. Step number 1, we have this cartilage model that's here, and again, this is all hyaline cartilage. But what happens is there's a perichondrium that's formed, so this is going to be ultimately become or give rise to the periosteum here. And so this perichondrium will form, except on the ends here of these long bones. This is going to remain cartilage, and eventually will become the articular cartilage of the long bones, where 2 bones are going to meet together. But this cartilage right here forms that you have this perichondrium that forms around the outside. In the next step, we see that we are seeing that perichondrium become ossified here in a process that we had described earlier. And then we have this calcified cartilage right here. So again, this is where those chondrocytes are going to mature and begin to become lay down the calcium phosphate around them a little bit, and then they're eventually going to die. So we get this periosteum now formed, and this periosteum is now called a bone collar. And you can see that how this would be a collar. This is going all the way around, right? All the way around the bone, and then through the backside as well. So this bone, this bone collar here is forming around the diaphysis of this long bone. So if we continue on with this process, we're going to see this calcified cartilage here in the center. Eventually, those chondrocytes are going to die, and you're going to get osteoblasts that are forming in here, and then you're starting to form little trabeculae that are there. And at the same time, you have this blood vessel that's going to now grow into that past that bone collar, and this is delivering nutrients, delivering the calcium, and removing any sort of waste products here that are involved with this ossification. And this is how, of course, the osteoblasts are getting into this site as well. And so where this is all forming this diaphysis of the bone is called the primary ossification center. Right? And we can see there then that these calcified cartilage is now spreading up this way. This is becoming more calcified in that direction, and this is becoming calcified. This hyaline cartilage model is being calcified down toward the epiphyses right here, and then up toward the epiphysis on this side. This process continues until you have this bone collar that is growing and becoming more less sort of cancellous bone and more sort of compact bone there. And then at the same time, you have these secondary ossification sites that are beginning to these secondary calcification sites rather in the epiphyses here. So we're getting this calcified cartilage, and this is secondary to, of course, that primary ossification center, that primary cartilage forming center. And so the same process is going to happen here in the secondary calcified cartilage area, where in the epiphyses now you have the same process where the chondrocytes are going to grow and enlarge, and they're in a process called hypertrophy. They're then going to begin to lay down calcium. They will then die, and the osteoblasts will come in here and start replacing that with actually bone there. In the meantime, this calcified cartilage is growing, right, outward, right, from this is becoming calcified, sort of out in this direction in every plane from that secondary ossification center, and this calcified cartilage is becoming, this cartilage here is becoming calcified, right, and so you have that process happening this way. So you can see what's going to happen is that this secondary calcification ossification site is going to meet up with this primary ossification site that is growing from the or forming from the center there. And eventually you carve out this medullary cavity, osteoclasts do, and then yellow marrow will replace the red marrow that is in there in the younger bone. Right? So here in the step 6 we see this just a continuation of this and more advanced, and then finally in the adult bone, in the mature bone, you have all of that hyaline cartilage has been converted to bone. Here there's compact bone, this cancellous bone. The epiphyseal line here is compact bone, used to be the epiphyseal plate. Right? And except on the edges of the long bones, you have this articular cartilage that still remains in place, right, to help form the joint there. Right? Under X-ray, we can see this epiphyseal plate, and the plate again is still cartilage, right? And so we have this little bit of shading that's there, and there's shading here, there's shading here. So this is the plate. This would be equivalent to this epiphyseal plate down here in the cartoon that is cartilage still. So this would indicate that this bone is still not yet mature all the way, not yet an adult bone, right? And is still forming, still becoming ossified there. So that's the formation of the bone. This is how we get the bones themselves in place. But then before that becomes completely ossified, the bone is actively getting longer, right, as well as wider. So the bone growth in this direction is called appositional growth. So appositional growth. And then growth in this direction, right, here is the longitudinal growth. Longitudinal growth. And so you get this epiphyseal growth is what they are describing here. And the ossification is happening sort of in this, like as I indicated before, out in every plane. So the cartilage is being laid down. You have more and more cartilage cells being produced in growing bone, and eventually those cartilage cells stop reproducing themselves, and you get this adult bone where there's no more cells produced, there's no more cartilage model that's being laid down, and the ossification centers are completely ossified, and you don't get any more growth, either appositionally or longitudinally. And again, this appositional growth here is this growth in diameter. Okay, so that is the formation and the growth of the bone, and this is what we see. Just a summary on the left here. Again, this is the bone growth. But as we age, and as we are age and still continue to have active osteoblast, osteoclast activity, osteocyte activity, the bones are constantly being remodeled. Right? And by remodeling, we are sort of recycling the bone. Right? So you have calcium phosphate that's going to be broken down, and then calcium phosphate that's laid down. And so this is how we get the different shapes of the bones. This is how the bone is constantly sort of replacing itself, is through this process of remodeling. And so in the different shapes of the bones are the different rates of remodeling that's happening here. But you see this bone being resorbed, right? And so this is sort of a negative process. So the bone is being broken down there, right? But then bone being added by appositional growth is building that up, right? And then bone being broken down here. So what they're saying is that, or what's happening here is that this is the original plane of the bone, but then the bone has a little bit more narrow diaphysis here and a little bit wider epiphysis here. That's because some of the bone was broken down and taken away here, right, as well as here, right? And you get that, or sorry, bone was added here, sorry, bone was added here, right? Bone taken away down here. These are supposed to be little X's, bone taken away, and you get the growth and the formation of that bone, right, because of the remodeling happening there. So this is just a little animation that shows you this compact bone remodeling, this concept here. So we have this longitudinal section, and here it is in transverse section. So we've got these osteoclasts coming in here that are breaking down the bone, resorbing it, and then osteoblasts follow there. They will come in and secrete calcium phosphate and lay down a new bone. And then those osteoblasts are become osteocytes. They are then removed out of that area. They'll actually migrate out of there. This is how you're going to form this osteon. And then you're going to see blood vessels and nerves grow into that haversian canal system there. Right? And here comes your blood. Right? So this is, again, that process of remodeling happening. Okay. So I know that might have been confusing in a couple of different places, so find where you are confused and bring those questions to class. But you basically should be able to describe here the bone formation in a fetus that is going from hyaline cartilage models to a full ossified, calcified bone, and then describing the events of bone remodeling. Okay, thanks for listening.